Hi, this is Dr. Pat. We're looking at compound interest. And so let's have some fun. The key thing about compound versus simple interest that was before is this time we're earning interest on the interest. So not just the amount of money that you put in, we're also getting money on the interest that we accumulate as well. So the dollars amount that you put in plus that interest, that percentage that you get, that's compound. Okay, now to get this idea across, I'm going to look at tuition and just kind of illustrate a compounding situation. So we've got tuition for 15 credits in 2011 was 1045, and they've decided to increase tuition by 10% for each of the next 2 years. What's the tuition in 2013? Okay, so that's what we're looking at. All right, so let's do our first calculation. So I'm going from 2011 to 2012. What's the projection for the tuition? We started with 1045. We're going to calculate 10% of that, and then we're going to add it to the 1045. And when you do that calculation, we get 1149.50. So this part right here, this 1045 times 10%, that's indicating how much we increase in tuition. That would be like your interest for a savings account. And then for the next year, the key thing I want to bring your attention to is that for the next year, we're actually using the 2012 number, not the 2011 number. Okay, so we're not going all the way back to 1045. We're using the previous year's amount. And so that's what happens with your savings account when you're calculating just on the single amount, how much you deposited or you put in. That's a simple interest. When we start adding the interest, adding the change amount to get a new balance, a new number, and then we use the new number in our calculations for the next increase, that's compounding. Okay, so that's the key point. Using the previous year, not the original one at the very beginning. Okay, so when we do another 10% increase, we add it to the previous year's amount and would be looking at 1264.45. And so that's an example. Now, is there a way that we can shorten this thing down? So if we've got this compounding situation where we're calculating and we're using the previous amount, do I have to go through and do each year's so that I can use it in the following calculation? We're going to find out there's actually a shortcut. Now, let's start looking at how we can shorten this thing down. We have a 10% increase. One way that we can play this 10% increase is to shorten down the calculation as 1.1. That's basically doing a 10% plus the 100%. And that's how we can shorten down the year by year calculation. Instead of going 1045 plus 1045 times 10%, we can shorten it down and just go, oh yeah, 1045 times the 1.1. So 100% plus 10%. And we can do that the next year. The 1149.5 times 100% plus 10% times 1.1. And as you can see, when doing this shortened version down, we actually get the same amount. So if you go back to the previous slide, we would see 1264.45. Okay, so that's one way of shortening it down. Instead of doing the addition, we do the changing of the percentage, this multiplier. That's how we play it. Now there's even another shortcut we can use. Hey, we started with 1045, we multiplied by 1.1. We got this number. And then we multiplied by 1.1 again. Well, the shortcut to that is to use powers. So we started with 1045, and we can do this as 1.1 to the 2 power. That means multiplying 1.1 times 1.1 again. So that's how we can shorten this down. So over a 2-year period, we have 2 changes. We can shorten this down mathematically as powers. So we start with the amount that we started with, the 1045. We indicate how things change, and then we have a power indicating how many years, how many times we change. Okay, so that's our shortcut there. And what would we have here? We have our beginning amount. The 1 right here represents adding on, accumulating. Remember, that's that 100%. The growth rate right here we have, that 0.1 represents the 10% growth rate that we have, adding it onto the 1 there. And then our power 2 represents the number of time periods. Now we can actually change this and make this a nice formula. So what used to be the beginning amount we'll call present value, PV. We've got our 1. This is the 100%. That's why it's in this formula. We've got our interest rates. So we're increasing 10%. So that's our interest rate. That's our that's our rate of change, percentage rate of change. And then our N up there represents the power, represents the number of compounding periods. How many times do we do a 10% increase or an increase of that thing? Okay, so we got beginning amount, we have our growth rate, we have the 1 because it adds on, accumulates, and then we have the number of time periods. So basically very similar to what we just had previously. I'm just now using the letters. And when we put this all together, we make a nice equation that this is equal to the ending amount, which we call the future value. So what we have right now is we have a formula for compounding situations. It's different from simple because you have a power up here because we're multiplying, because we're using the previous amounts. We're multiplying the previous amounts, and that's what this formula does. Whereas simple interest had that n down here multiplying to the I. And that's the key difference between compounding simple interest in terms of the formula is the position of the number of time periods. And so that's what we have. So hopefully this makes some sense to start things where we get this formula, and then we'll use this formula in some business examples in the next video. Thanks.